Hello, everyone. This is the Human Impacts on Water lecture, and I wanted to spend some time thinking about the two main factors how humans are affecting our natural water systems, and that is dams and levees. So let's start thinking about dams. The U.S. has over 75,000 dams, and basically what we see is any river of any size has a dam on it in the U.S., right? Where there's only 42 high quality river sections that we call them, and that what that means is where there's over 200 kilometers of river, 120 miles that doesn't have a dam on it, and there's only 42 places in the entire lower 48 states that we can find that happening. And of those 42, I think all of them have at least dams on some part of their rivers. Now, dam building is actually slowing down worldwide. We're not building as many dams because essentially every large river in Europe, North America, the former USSR has a dam on it, right? All of this good sites, all the best sites for dam building have been used up. But it's also somewhat realizing the consequences of what of some of the bad things about dams. So dam building is slowing down. But dams do some good things. Water storage. So we just got done talking about how Lake Mead stores water for Las Vegas. There's a lot of reservoirs in California that store the water it's a chaparral biome, remember, so it gets a lot of water in the winter, and then they have a dry spring, summer, and fall, so they need to store water in these reservoirs so that they can have drinking water year round. The rivers along the Missouri River Basin, so the reservoirs, I should say, along the Missouri River Basin, Fort Peck Dam, Garrison Dam, Oahe Dam, these are huge reservoirs that fill up with huge amounts of water and prevent flooding they don't only just prevent flooding, along the Missouri River here, but they prevent flooding once they already get over to St. Louis and Mississippi, flooding along the Mississippi River. The Mississippi River, though, is also heavily dammed for navigation purposes. They have these what are called low-head dams that allow barge traffic to flow all the way from Minneapolis-St. Paul down to Louisiana and the Gulf of Mexico. So we also shouldn't forget hydroelectric dams, right? So pretty much every dam that's built has some sort of hydroelectric power plant connected to it so that they can get some extra benefit from that flowing water. Countries like Iceland has over 80% of their electric grid is based off of hydropower. Norway does a lot, and then other countries do use hydropower to some extent. There's pretty much every country does, but it just doesn't make up a huge portion of most other countries' way in which they get their electric energy. So the question is, okay, these are some good things. Are dams actually economically profitable? Like, is there money to be made by making a dam? And that becomes a tricky question because we know that once you stop the flow of a river and don't let it flood, which is one of the main reasons why we built dams, is you're not going to have a bunch of natural fertilizer. So when you stop these floods, about 20% of the electricity generated needs to be used to make fertilizer to replace those natural nutrients that are deposited. So right away, however much money you're making on that electricity, take away 20% of that money, and it's not. It's less profitable than you might think, and those are oftentimes not calculated in the equations that are given, or the amount of return on investment calculations that dam builders will be talking about. Then the reservoirs need to be maintained. It's very expensive to dredge reservoirs, and as a reservoir is built, the streams will fill up with sediment, and they'll need to be dredged, otherwise they're just going to completely fill up and be useless after a while. And that is oftentimes not considered when thinking about the profit margin on a dam. Then, is the dam going to break? We kind of need to have a risk analysis of what is the probability that a dam will break and how much money is that going to cost. And these are some, I'll just let you kind of look at these numbers over here of some either high profile or these are some of the two more closer, more recent dam breakages that I've seen, and this is one of the biggest dam failures that we've seen in the U.S. that was extremely expensive to fix. So from an economical perspective, yes, they probably are profitable in the long term, but not as much as is normally explained. Ecologically speaking, though, dams are pretty terrible. The sediments are oftentimes gotten, the river is starved of sediment, so when it goes downstream, the streams will pick up sediment, and you also alter the hydrology, so the how much water is flowing down the stream can be changed because there will be water extractions from the reservoirs, which can cause problems. And then temperature difference. If you take water from the top of the reservoir, it will be very warm and could have high oxygen, but it might be too warm because the water, it might be low oxygen because the water is too warm. So if it was a cold flowing stream, it might screw up things for the organisms that live downstream. And then we've talked a little bit about migration and how fish will be using these fish ladders to try to get to different ways, and we'll try to get around migration barriers that the dams are. But again, not all fish can use this. So ecologically, we kind of know that dams are not great. They cause some problems, might be economically profitable depending on the specific scenario, but ecologically, dams cause a huge amount of problems. So let's think about levees then. So the main purpose of levees is to create wider, deeper, straighter channels. What that means is it gets the water out of the river quicker, right? So the straighter the river is, the wider it is, the deeper it is, the water can flow faster. And if you take out, trees and wood that has been, if it's going through a forested area, there might be a decent amount of obstructions in the river. Remove those out, and you get a quick flowing river that drains the land quickly for agricultural land. It also can help the river then avoid floods. So a lot of people are, fall for straightening rivers and putting up these levees so that protects their lands from getting flooded. The problem with that is levees will overtop, right? Given enough time, their levees will break. They need to be continually maintained because the river will continually try to erode them, and the levees will be broken on pretty much any river given enough time. What we're seeing is that with climate change scenarios, we're going to have about the same amount, at least in the Great Plains portion of the U.S., we're going to have the same amount of rain, but it's going to be in more discrete packets. So we're going to have we're going to have fewer storms, fewer rain events, but they're going to be bigger storms when the rain comes, which is bad if we're trying to prevent flooding. And, the Mississippi River used to flood 80 miles wide. There's no way that, levees are always going to be able to protect the with that amount of water coming down the river at one time, there's no way that levees will be able to hold that back. So one of the solutions to levees has been, what if we set them back? So the normal kind of where we would put a levee is if a river was right here, we would put a levee right next to it, so that when the river floods, well, you just get a deeper channel. But and it prevents this farmland from basically, or city, it doesn't matter what it is, from getting flooded. The the thing that what people are suggesting now is do not build a levee right next to the river. Set it back. Either pick up the levee and move it, with just bulldozers and things like that. And what you're doing then is you're lowering the probability that those levees will break, because you're increasing the amount of, the whole capacity of this river channel is now much more to be able to more. It's basically like a bigger pipe to have water flow through this system, right? So the levee is less likely to break. It allows some access to the floodplain, so the organisms, the fish that are used to spawning in a floodplain and are going to be a lot happier. And the thing is, a lot of people do not like this idea, because it's a lot of people say, well, that's a bunch of wasted land, right? So if we take the levee and move it back a kilometer, so maybe a half mile or something, right? The farmers that were farming that land, or the city that was right here, is going to be not super happy about that, right? And so we're basically saying, okay, that part of the river is now, this part of the land is now just fully for the river's use, which can be good for some things but bad for others, right? And if we are actually moving a current levee, so this is some of the costs that we would expect per river mile for restoring a river and moving levees. And it's extremely expensive, right? So a reasonable mean, $129,000 per river mile. And the number of river miles that we have that need restoration, that need these levees to be moved back, and that we're doing that, that would just be prohibitively expensive, and we don't have the money for that. Essentially, all U.S. major rivers need some sort of restoration. So that's basically not as realistic that it's going to happen. So I hope you enjoyed spending some time thinking about how dams and levees are affecting our rivers. And with that, I'll see you later.